elettronica, ha un laboratorio da scienziata dentro casa ed è socia di questo Bionomica Labs di New York. Ci viene a raccontare il futuro del biohacking. Cristina Cipriano. Benvenuta. Sei a posto? Microfono? Vai.
Ciao.
Ciao.
Perfetto. Okay, good morning, everyone. So I'd like to start by asking you a couple of questions. The first question that I want to ask is, wait, I think I'm going back. Why is it starting here? Okay, here we are. I'd like to start by asking, why are we teaching questions that we already have the answers to? Why are we making students do things that have already been done? I'm an independent researcher, and during the past few years, I've built a molecular biology and electronics lab in my own apartment here in Italy. And currently, I'm exploring the most diverse topics and fields of knowledge while reaching out to a variety of students. Developmental psychology evidence shows how human babies reason with the natural world, and this trait is an evolutionary survival mechanism. By that logic, the ability to conduct science is built into each one of us. So all we need to do is have access to the tools and guidance so for those who have experience, so that we may progress faster than they have. So there are over 8.7 million eukaryotic life forms on this planet, and more than 80% of them have yet to be discovered. This means that there is a multitude of questions, an infinity of questions that still haven't met the answers. And there are an infinity of phenomena to still discover and study. So in order to meet these questions, we need to be working on them. Science at its core is a narrative. It's a story, but it's steeped in facts and evidence. The tradition of storytelling has grown with us. We are all able to weave a tale of our experiences. The only difference with science is that the scientific method is a way of applying rigor to these experiences, so they don't succumb to the fallibility of human excitement and belief. So what we teach in terms of what science truly is tends to be lost within the topics of what science entails. Once we realize that science is systematic storytelling, we can free our minds to explore curiously, and questions that were left abandoned would finally meet the answers. Scientists work to tell the stories that they are studying. These typically become publications in in scientific journals, but public access is often restricted by expensive paywalls. To counter this phenomenon, there's open access, which is a way of democratizing information, reducing disparity, and promoting equality. We may have some of the greatest minds of our generation, but they may live in a remote region, and they don't have access to these things. They don't have access to this content. So, but it's not just a problem of remote regions, because budget cuts in institutions often result in restrictions to scientific literature access, which limits the possibilities of researchers. And since there is so much to discover, and understand, we need to enable and enhance interdisciplinary research collaboration. We need to share our stories. So open access also means inclusivity, something that science has had trouble doing over the ages, because where science has become more competitive, makers are collaborative. So our current challenges are so complex that the modern practice of science can only learn a lot from the way open access, open source projects work, and the way that they're managed, and the way that everything is credited, right? So this is so experience participating in a community lab and observing what others are doing and what they're doing with their tools gives a chance for people who are observing to learn, right? So we develop a sense of which tools are appropriate for which job. And if you think about it, a lot of molecular biology is pretty much the same thing. It doesn't just happen in the maker world. So more experienced scientists do the same thing as makers do. They teach, they act as mentors for others, and they lead the way to the use of tools and techniques. But I realize that it can be hard to see yourself as a maker or as a scientist, because it can be intimidating at first due to the lack of experience that one has with these tools. And when you don't have a general picture of what's going on, it can be a little bit daunting. So we develop, the thing is that we need to remember that none of us start knowing what they're doing. So we learn over time through practice projects, and especially with prolonged engagement. So my story begins at the intersection of these two worlds. I am basically a hybrid between a maker and a scientist. And what I have learned is that being a scientist or being a maker relies less on inherent abilities or skills, or intelligence for that matter, but it's just a matter of having a positive outlook and the will to learn, to understand what we're missing, and so what skills I need to acquire in terms of what I need to do with my research. So 2 years ago, I bought my very first 3D printer, and it changed my life by starting a lab. Basically, a 3D printer is a tool that is able to generate new tools. So I had previous experience in scientific laboratories, and I had familiarity with these tools, but I also knew I knew of science's high expenses. So I wondered, what can I do to make my work more accessible? What can I do to really reach people and make my story not just my story, but a story that everybody can share, so that others can do the same things that I have been doing? So what I did is I decided to lower the costs of typical scientific instrumentation, building many optical devices and tools to work on DNA, and I all built these on my own. I used just few electronics components and many hours to come up with clever solutions for my instruments designs. Within a year, I managed to innovate these tools, the main tools of a molecular biology lab. And I lowered the costs of each one of these tools for under 20 euros tops. So I did not just replicate existing tools. I tried to change them in some little limitations that even the more expensive tools still have. So this obviously does not detract from the functionality or utility of the more expensive scientific equipment, but there was room for improvement, right? So besides being expensive, many molecular biology devices are cumbersome and depend on current. What I wanted to do, though, is create a portable lab, something that you can recharge, like you can use in places where you don't have access to electricity. What do you do in those cases? Because there are areas and regions in this world where science needs to be done. But the problem with these regions is that it's not only about electricity, but also some of the biological samples cannot be always taken back to a lab. So what do? Do we just stop studying it, we just don't study it. No, we need a solution. So creating tools that can be rechargeable and that you can bring with you and that are low cost can be really useful, not only in developing regions, but also for bench space. If you think about it in a lab, bench space is basically premium real estate, right? So you always want to have as much space as possible, and having a small tool surely can be useful. So I'm not trying to propose a different kind of science here. This is what is important. So what I'm trying to do is share my stories, right? Share what I'm doing, be collaborative with others in a way that these tools can be adopted by other people, and they have been adopted by other people. They're using them in universities now. Students are using them as well, guided by their own mentors and even hobbyists. Anyone can do science, and this is what I'm trying to say. Like, I'm not trying to propose a different kind of science outside of formal settings. All I'm trying to say is we can add the best parts of maker culture into it. So science is science. You either do it by following its standards, or it's not science very easily. So when I say everyone can do it, I mean kids can do it. A kid will dare to ask the questions that adults sometimes forget to see or don't notice sometimes, right? So they see the world with fresh eyes. They have a different perspective, and it's valuable, and it's also very useful. Makers and scientists can both learn from each other, and they also can learn from kids as we teach them. We all have in common the incredibly beautiful quality of curiosity in common. So let's not forget how to be kids. All we need to do is give structure to our playtime so we can all generate new knowledge, right? How can we all generate new knowledge? So this is Bianca. She is an 11-year-old that I had the honor of teaching. And through the nonprofit that I work with, which is Bionomica Labs, Bianca structured her own study on a common weed that is called Oxalis stricta. We helped her gain confidence with the tools and the protocols, but she did all the work on her own. And she won first prize at a local science fair. Another example is an open access scientific journal here we can see, and this is a publication done by children from a primary school in England. And there wasn't even a big city in England, it was a rural city in England. So they were helped by their teachers, but eventually they were able to answer new questions in science. And then there's Werewolf. These are a group of students from New York's Fashion Institute of Technology, and they had no background in biology whatsoever when they came to us. And in only 8 weeks, they were able to create a sustainable protein fiber for the fashion industry and a kit to synthesize other ones. And they won the award for best presentation at the Biodesign Challenge in New York this year and a contract with Ralph Lauren. So, I see an impact, and I see it, it's tangible, it changes people's lives. During last year's workshop here at Maker Faire, Giulio built a microlarimeter, and he was helped by his friend Paolo. A year later, Giulio changed the build of that device, and he made a better version of it. So I've inspired different people to start 3D printing, some of which are kids. Others are girls who were first afraid of even entering the field of engineering. And the thing is, now they're all doing their own designs. They're creating their own designs. Other people got involved. I visited many universities and got valuable feedback. And we empowered and learned from each other, and this is our spirit. But I'm not the only one with this vision. This is my second family, basically. Each one of them has a unique background. Some are artists, others are scientists, engineers. Some are musicians, or a mix of all these things together. But we all have in common one thing, our love for biology. So our projects may be different, but our goal is the same. we are trying to promote a new way of pursuing science, and specifically biology. We are the Global Community BioSummit participants, and each year we meet up in Boston at MIT. I will be seeing them in 2 weeks. So science may seem daunting. It has obstacles, for sure. It requires passion, it requires time, and there are going to be a lot of mistakes during the whole process. But that should not scare us, because we all carry the greatest tool that we have, and it's all up here. We have it for free. So we should really learn how to use it responsibly. This is my story, but the next story can be yours. And I cannot wait to share it with you and learn from you.
Grazie Cristina, grazie.
Grazie.
Perché in inglese?
In inglese perché ho fatto questo pensiero tra me e me in realtà, però penso che essendo ormai la lingua con cui parla il mondo è anche un modo di raggiungere più persone.
Così questo video della
più
Maker lo
discorso.
puoi condividere con il tuo mondo internazionale.
Sì, in realtà il mio network è quasi tutto in inglese, quindi chiaramente per una questione di maggiore adattabilità al discorso.
Grazie per la passione. Grazie.